Every time you type a website address, something invisible happens before any data can even begin moving.
Computers do not understand names or words, they only understand numbers, which immediately creates a hidden translation problem.
DNS exists to solve that problem by translating human-friendly names into the numerical addresses computers actually use.
Before your request goes anywhere, your device quietly asks one question about where that address should actually go.
The answer does not come from one place, but from a distributed system built to respond quickly and reliably.
Everything starts with a local DNS resolver, usually provided by your internet service or your operating system. If the answer is not already known, the resolver begins asking other servers across the internet. The search begins at the root level, which does not know the answer, but knows where to look next. From there, the request moves down to top-level domain servers that narrow the search further.
Finally, the authoritative server responds with the exact numerical address the computer needs.
That answer travels back through the same chain until it reaches your device again.
Only after DNS finishes does your browser know where to send the actual data request.
To avoid repeating this process, results are cached locally for future requests. When a cached answer exists, the browser can skip the entire lookup process. This entire system usually completes in milliseconds, without you ever noticing it.
When DNS fails, the internet feels broken, even though everything else may still be working. Without DNS, your computer has no idea where to send requests. DNS acts like a constantly updating phone book for the entire internet.
Changes spread gradually, ensuring stability instead of instant global updates.
This trade-off keeps DNS both fast and reliable at massive global scale. DNS is built in layers, so no single server ever needs to know everything about the internet. Each layer handles only a small part of the naming system, which keeps the entire network manageable. This design allows DNS to scale globally without slowing down as the internet continues to grow. If one server fails, others quietly take over, often without users noticing anything at all. Redundancy is a core principle that keeps DNS reliable under constant global demand. Most DNS lookups complete so quickly that users never realize a lookup happened at all. DNS always runs before any real data moves, acting as the internet's quiet first step. When DNS breaks, websites appear offline, even if the servers themselves are still running.
Switching DNS providers can sometimes restore access without fixing anything else.
DNS quietly controls how users reach services across the internet. It can direct traffic to different servers based on location, load, or availability.
The same domain name can resolve to different servers depending on where the request comes from.
This helps balance load and improve performance without users ever realizing it. DNS decisions can significantly affect speed, reliability, and user experience. This system runs constantly, handling billions of requests every single day.
Most users never think about DNS, yet they rely on it constantly. Without DNS, the internet as we know it simply could not function.
It quietly connects names to numbers, enabling everything else to work. DNS rarely draws attention, but its role is absolutely critical. DNS is how the internet turns names into connections every single time you go online.